Hey everyone, this is teacher AJ, and we will be talking about the Earth systems. So, for our learning competency for today, we should be able to explain that the Earth consists of four subsystems across whose boundaries matter and energy flow. So, let's start. Earth is characterized as the blue waters, rocky brown and green land masses with white clouds. It is the third planet from the Sun and the fifth largest in the solar system. The Earth is also subdivided into four spheres. We have your Geosphere, Hydrosphere, Atmosphere, and Biosphere. And we will be learning one by one about these subsystems. In summary, our Earth spheres are the lithosphere, which is a solid part of the Earth. We also have here the atmosphere, where all the gases that surrounds the Earth or the air. We have the hydrosphere, that all the water found on, under, and over the surface of the Earth, and biosphere, all lives on Earth. And these spheres interact with each other to support life. Let's start with the first sphere, which is the geosphere. It makes up all the solid portion of the Earth, and it is a structure and land. Came from the Latin word geo, which means ground, and it also comprises the layers of the Earth. What are the layers of the Earth? Back in your earlier days or earlier grade levels, you were taught about the layers of the Earth. We have your crust, you have your mantle, your outer core, and inner core. And that is the estimate or average kilometers or the size of our layers of the Earth. We have for your crust, it's 5 to 25 miles or 8 to 40 kilometers. You also have there your mantle, 2,900 kilometers. Your outer core at 1,400 miles or 2,250 kilometers, and your inner core at 1,300 kilometers. Let's talk about the crust. The crust is the outermost layer of the Earth. It is a thin layer composed of solid rocks and minerals with temperature of 22 degrees centigrade. It is divided into continental and oceanic crust. The continental crust, the crust under which the continents are built, is 10 to 70 kilometers thick, while oceanic crust, or the crust under the oceans, is only 5 to 7 kilometers thick. You have here a picture of the deepest mine shaft ever built, the Western Deep South Africa. Currently reaches 3.9 kilometer, which barely scratches the surface of the continental crust. Because remember, the continental crust reaches from 10 kilometers to up to 70 kilometers. Let's talk about now the next layer, which is the mantle. The mantle is the largest layer composed of rocky oxides and silicates under high pressure. Once thought that the mantle contained liquid magma, but that is not the case. Magma is formed only in certain locations due to the high pressures and temperatures. The mantle is huge, going down to a depth of 2,500 kilometers. The Asthenosphere, the zone of Earth's mantle lying beneath the lithosphere and believed to be much hotter and more fluid than the lithosphere. The mantle is sometimes split into upper and lower mantle because the upper part moves and flows in the convection current much more easily than the lower part. Even solid rock can move and flow at this high pressure and temperature, though it moves very slowly. Okay, so the mantle is a site for the convection current, why the tectonic plates move. Now let's talk about the core. The outer core is a liquid that flows in circles, and it is a source of the magnetic field. The inner core, on the other hand, is a solid part that believed to contain at least 90% iron. The outer core goes from a depth of 2,550 kilometers down to 4,750 kilometers, and the inner core continues to the center of the Earth at a total depth of 6,470 kilometers. The liquid flow of the outer core is responsible for creating the Earth's magnetic field. On Earth, flowing of liquid metal in the outer core of the planet generates electric currents and the rotation of the Earth on its axis because these electrical currents or electric currents to form a magnetic field which extends around the planet. If you can see in the picture on the upper part, we have here your the flow of magnetic field. Okay, that's why when we are using our compasses, it's not actually pointing to the north, but rather it's pointing to the magnetic north, which is a little bit of tilted from the north that we have. And the picture below is showing the aurora borealis, where it is the showing of ions or activation of ions in the magnetic field. Okay, let's move on to our next Let's move on to our next subsystem. We have here your hydrosphere. The hydrosphere is composed of all waters or near the Earth's surface. The frozen part is called the cryosphere, or usually situated at the top and the bottom of the Earth. Hydrosphere is 97. Mostly of the 97% is in the form of ocean. The rest is fresh water. Three-quarters of this fresh water is solid and exists in the ice sheets. So if you would notice in the picture, in this slide show, I mean in this slide rather, that there's a little bit or just a little part of fresh water that we are able to use for drinking, for usage, and those are now your groundwater because part of this fresh water are encapsulated in ice caps and glaciers. Okay, and of the surface waters, we have your lakes, rivers, and swamps. And 97% of the water are saline water or usually from the oceans and seas. And we could not utilize this for drinking, for using or to be used in our daily lives. So this is now the hydrologic cycle, the water cycle, starting with the evaporation of water and cloud storage. And once it's full, it will be precipitated to the lands and moving up now to our oceans again and even to our tables. Okay, let's now talk about the next subsystem, which is the atmosphere. We have here the atmosphere as a blanket of air that surrounds the planet, contains essential gas necessary to sustain life, and it protects us from harmful radiation, drives ocean and spreads heat which regulates the climate. Because again, it contains now the ozone layer. Again, we have in our previous video, we talked about the composition of the earth, the atmosphere rather. We have here your nitrogen, your oxygen, your trace, your argon, your carbohydrate, carbon dioxide, and all. Okay? The layers of the atmosphere. We have here the exosphere, the thermosphere, the ionosphere, the mesosphere, stratosphere, and troposphere. One by one, we will be discussing them. Troposphere, layer nearest to the Earth's surface, extend to the surface up to 8 to 14.5 kilometers high. The densest layer since it contains about 75% of atmospheric gases. As altitude increases, the temperature drops significantly. The upper boundary of the troposphere is the tropopoles. So while we are going up to the troposphere, again, there is a notice or a significant drop of temperature. So it's getting colder. In the troposphere, all cloud types, storms, and all the weather phenomena happens in the troposphere. Okay. In the stratosphere, let's talk about now stratosphere. Layer immediately above the troposphere extends about 50 kilometers high. Compared to troposphere, this layer is less dense and relatively dry. Strong steady winds, absence of clouds and vapors, and warm temperature characterize this layer. Temperature is higher than troposphere. In the stratosphere, the ozone layer is also present, which absorbs now the ultraviolet radiation and transform it into heat. The upper boundary of this stratosphere is called stratopause. The stratosphere contains a thin layer of ozone molecules with three oxygen atoms, which forms a protective layer shielding life on Earth from the sun's harmful ultraviolet radiation. But this ozone layer is being depleted and is getting thinner over Europe, Asia, North America, and Antarctica. Holes are appearing in the ozone layer. Ozone is an unstable bluish gas composed of three atoms of oxygen. So it's very important for us to take care of our atmosphere by decreasing our air pollution contribution. Okay. Let's talk about now the next sphere, which is the mesosphere. This layer starts just above the stratosphere and extends to a height of about 85 kilometers. The temperature drops significantly in this layer, as low as negative 93 degrees Celsius, as the altitude increases. The coldest layer of the atmosphere. Here in the mesosphere, the atmosphere is very rarefied. Nevertheless, thick enough to slow down meteors hurtling in the atmosphere, where they burn up, leaving fire tails in the night sky and showing as our nature fall. Okay? The thermosphere starts just above the mesosphere and extends about 600 kilometers high. The temperature is hot and may be as high as thousands of degrees, as a few molecules that are present in the thermospheres receive extraordinary large amount of energy from the sun. The high-energy X-rays and UV radiation from the sun are absorbed in the thermosphere, raising its temperature to hundreds or at times thousands of degrees. However, the air in this layer is so thin that it would feel freezing cold to us. In many ways, the thermosphere is more likely outer space than a part of the atmosphere. Many satellites actually orbit the Earth within the thermosphere. The thermosphere, the aurora, the northern lights and the southern lights usually occurs in the thermosphere. The ionosphere. The ionosphere is not a distinct layer like the others mentioned above. Instead, the ionosphere is a series of regions in parts of the mesosphere and thermosphere, where high energy radiation from the sun has knocked electrons loose from the parent atoms and molecules. The electrically charged atoms and molecules that are formed in this way are called ions, giving the ionosphere its name and endowing this region with some special properties. And lastly, let's talk about the exosphere. Although some experts consider the thermosphere to be our uppermost layer of the atmosphere, others consider the exosphere to be the actual final frontier of Earth's gaseous envelope. Air in the exosphere is very, very thin, making this layer even more space-like than the thermosphere. These are now the major regions of the atmosphere and the altitude and the temperature range. Important chemical species in the troposphere, we have your nitrogen, oxygen, carbon dioxide, and water. You have your, in the stratosphere, we have here your ozone gas. In the Mesosphere, we have your oxygen, nitrous, nitrous oxide, and others. And for the exosphere, we have your hydrogen and helium. And lastly, our last subsystem is the biosphere, zone of life. It is a globe in the biosphere is the global ecological system integrating all living beings and their relationship, including their interaction with the elements of the lithosphere, geosphere, hydrosphere, and atmosphere. The biosphere is the part of the earth where all life exists. The biosphere extends from the deepest root systems of the trees to the dark environments of the ocean trenches to lush rainforests and high mountain tops. The biosphere measures about 20 kilometers from the top to the bottom where almost all life exists, between 500 meters below ocean surface to about 6 kilometers above sea level. It ranges from a height of 10 kilometers above the sea level as well as below and the ocean surface to about 6 kilometers deep. So again, this is our biosphere. Again, the four subsystems of the Earth is the Geosphere, Hydrosphere, Atmosphere, and Biosphere. Thank you for watching. Have a great day, everyone. Goodbye.